All right, let's get started. So, menu for today is to wrap up polymorphism. We are this close to the end, okay? So I just have a little bit more lecturing to do, like traditional lecturing with slides, etc., to introduce one last concept. And then what we are going to do is we are going to look at our book, ebook, audiobook example, okay, again, once more. And we're going to try to introduce polymorphism inside of it. But it's going to be obviously, to help you, one, understand the concept that we just lectured about for the last two sessions, okay? And two, prepare you for the next exam, give you an idea of what's to come, okay? So we are going to pretty much tinker with that example. I'm not going to try to make like a specific feature. I mean, there are going to be several features that are going to be implemented, of course. But what I mean is that I'm really going to try to take that code example as a base to apply everything that we covered for the last two lectures. Okay, tinker, try things, see what works, see what doesn't work, and so on and so forth. Before we dig into that, as usual, a few reminders. We have an holiday coming up. So next Thursday is Veterans Day. It's observed at USF. So no class, no office hours. Just wanted you to have a heads up so that nobody drives, on campus for nothing, pretty much. Where are we in the module? So we introduced polymorphism. Polymorphism means we can assign reference values that are of a certain type, the type of a superclass, to reference variables that are of a different type, the type of the superclass. And I said superclass twice, sorry about that. We can assign the value that is a type of the superclass or the subclass to a reference variable that is of the type of the superclass. That's been what we have been talking about for the last three sessions, okay? What method can we call when we have one such reference variable? Whether it's a parameter, an attribute, a local variable, doesn't matter, okay? This applies to all of those scenarios. What kind of methods can we actually call? We can call anything that is defined in the superclass, obviously, because the reference variable is of the type of the superclass. We can call everything that is defined in the subclass and override something from the superclass for exactly the same reason. Priority is given to the overridden version if you pass actually a reference that is a reference to an object of a type of the subclass. And then, what about the method that exists only in the subclass? This is what we focused on last lecture. So we saw that for the method that exists only in the subclass, we need to actually use a technique called explicit downcasting. So we went through the whole thing, okay? We explained what primitive data type casting was, then what upcasting was, the easy scenario, then downcasting. We have to make explicit downcasting, and it's tricky because sometimes it works, sometimes it doesn't work, and it depends on what's going to end up being in your reference variable at runtime when you try to execute the code. The compiler cannot predict that. Anything can happen at runtime, so the compiler is no longer useful for us to try to find problems. As a matter of fact, we ourselves pretty much unlock the safety from the compiler when we do explicit downcasting, so we are on our own. And so far, we know that downcasting is going to work when the object is of the right type, and we know we are going to have this information available to us only at runtime, but we don't have any tool, any technique yet for us to check the type of an object at runtime. So this is exactly what we are going to jump into for this session, okay? And this is the last bit that I need to add, and after that we are done with all the concepts you need to be equipped with regarding polymorphism in this class. What I would like to introduce to you is an operator. Unlike plus, equal, divided, multiplied, etc., this one is not represented by a symbol, it's represented by a keyword. The keyword instance of in one word. And those of you who are keen with that kind of stuff, you probably noticed already that this violates the camel case convention for identifiers. So the O should be uppercase, it's not uppercase. There are two exceptions like that in Java. This is the second one that we have encountered. We just have to deal with it, okay? So instance of is an operator that I can use, well, in expression, obviously. So here's a code example here where I have an if statement. somewhere in the middle of my code, I have an if statement. I have a polymorphic parameter to this method called myObject. It's been declared of type object. By the way, whenever you see a parameter declared as object, definitely that's going to be a polymorphic method. There are very few methods that just work on object and are not written actually to work also with any subclass of object, okay? So these are like pretty much the ancestors of generic, like in the sense of generic class, like array list. So I have my parameter, my object, and I want to check, is the actual object referenced to by my object, is it of type circle? Is it an instance of the class circle? Well, I use the instance of operator and I wrote if my object, so my reference, right, instance of circle, and that's going to inspect the object at runtime, check the data type, what class it has been fabricated with, and then tell us true or false. All right, if it's true, if what I'm dealing with is an object of the class circle, then that means that I have access to everything the class circle has to offer. Even though my parameter was declared as, reference to object, now that I know it's actually a reference to an object of class circle, I can do explicit downcasting here. This is what's happening here. Circle between parentheses, that's the notation for casting, typecasting, okay? It's downcasting because I'm moving from a reference to an object to a reference to a circle. So explicit downcasting. And once I converted this reference, I use it to access getDiameter, which is actually a method that exists in the subclass circle, but doesn't exist in the superclass object. So remember, the instance of operator is actually very useful. We're going to talk more about that, when to use it, when not to use it, okay? But it's very useful to have that in a programming language. However, you must remember that the definition of inheritance is transitive. So if I was to ask, is my object an instance of object? It would tell me true. Because object is not my direct superclass, right? It's not my direct class, actually, but it's my indirect superclass. If I was to ask, is my object an instance of, let's say we have that class geometric shape, that is a superclass of circle, right? If I was asking, is it an instance of circle, the answer would be again yes. Because it's an instance of circle, geometric shape is a superclass of circle, so it's both an instance of geometric shape and circle. So it's an instance of circle, its own class, geometric shape because it is a superclass, and then object because it's a superclass. And all of those expressions are going to come back true. So instance of is useful, but it's not the same thing exactly as asking what is the class for that object. Okay, I made it sound like we were going to detect the class for the object at runtime. Sort of. We detect if the object is compatible with a certain class. And that's going to come back to bite us at the end of the session during the wild coding. The wild coding. Live coding. All right. Why no parentheses after instance of? Because it's not a method call. Okay? It's one of the very few operator that is represented as a keyword in Java, so this thing is full of exception, right? It's one of the few, if not the only one that I can think of, operator in Java that is represented by a keyword instead of a symbol, but the rules do not change. When you do multiplied, x multiplied by y, you don't put parentheses after the multiply symbol because it's an operator. It's not a method. Same thing here. Even though the fact that we use a keyword may make it look like we're calling a method, we are not calling a method. It's just an operator in between the two operands, myObject and circle. All right. So, quick remark before we move on. Once we check that the data type is what we expect, once we decide that if my object instance of circle, then I do this when this evaluation of expression is true. That doesn't mean I still don't have to do the downcasting. Okay? That's a common misconception, is that, well, I checked that it was the right type, so I can go ahead and call my object dot get diameter. No, you can't. For exactly the same reason that we discussed, during the previous lecture. You cannot do that because the reference is a reference, the reference variable is a reference to an object. The class object doesn't contain get diameter. Who is going to get pissed at us? Method matching. Method matching is not going to let that fly by. So even though we detected at runtime with that if statement that this was actually an instance of the class circle, now we pretty much have the green light to go ahead and proceed and do a downcasting. But the difference is that we know that our downcasting will work. Because the if statement told us this is really a circle right there. So I can go ahead and say, let's look at it like a circle, and now let's do circle things with that object. Let's take another quick example. So we are going to create two geometric shapes, a circle, a rectangle. We are going to use them as parameter to a polymorphic method. So polymorphic method is going to be called display shape. It's going to take an object as parameter, and then it's going to use that technique we just saw to inspect what is the runtime data type of the object being actually referenced by the parameter, and decide, well, if it's a circle, I'm going to display the area in the diameter. So I'm going to assume I have a method get area, get diameter, whatever I need that is defined in the circle class, okay? If it's a rectangle, then there's no sense in me trying to display the diameter. I'm going to display the area instead, okay? Just the area. Okay, so how is that going to look like? Well, casting demo class, just random name, a main method inside of it, create actually an object of class circle, create an object of class rectangle. And I'm already using polymorphism here because I declared the reference variable object1 and object2 to be both of the data type object. Okay? So object is a superclass of circle, it's a superclass of rectangle, it's a superclass for everything. Okay? So we cannot be more generic than that. And then I call the method display shape that I'm going to show you on the next slide, and I pass object1, object2. So I do pass references that are of data type object, just like it was announced as the previous slide. Looking at the code for display shape, so it does take one parameter. The parameter is of data type object, and then it tests if object, the name of the parameter, is an instance of circle, then do this. Again, explicit downcasting that allows me to call the method that are specific to the circle, and then else, if the object is an instance of rectangle, then do that other thing and call a method that is specific to the rectangle. So all of this to answer that question, which was like one lecture and a little bit ago. The question was, can we actually manage to call on a polymorphic parameter a method that only exists in the subclass? And the answer is yes, we can, but it takes a little bit of work, and it kind of forces us to really understand what's going on with polymorphism and Java. So we finally got around to doing that. So what I would like to show you real quick, and I'm going to show you the code so that we have more time to do live coding, for the things that are a little bit more complicated. What I want to show you right now is I want to show you when it's inappropriate to use instance of. It's very tempting when you just discover instance of to use it right and left for a lot of things because it's powerful. It allows you to get full control about what's going on in your code, okay? But it's a mistake most of the time to use it. So let me open up real quick. What's going to be slide switch? Should be hidden somewhere. Did I hide it here? Yes. Let me open this up and walk you through the code here that we have. So the goal here, it's called switch OOP because this is this has become an expression, okay? Talking about switch-based OOP, that doesn't mean that I'm going to use a switch statement, but I could. But it means that the general idea is that there's going to be some sort of conditional structure in the middle of my code, and that conditional structure is going to take control and actually decide, what we do when we are facing this class or this class or this class. Okay? So that's called a switch OOP version of something. All right. Let's see, it will make more sense when you see the code, actually. So let's dig into the code. For the main method, I have an employee E, new employee, so nothing special here, no polymorphism even. I have a faculty F, new faculty, nothing special either. I call two static methods, one called with dynamic binding, one called without dynamic binding, and I pass to each of them first E and then F, and I want to see what's happening. So now we need to look at the definition of those methods to understand, what it is that we are trying to do. So let's go to the version that says without dynamic binding. So here we are, public static void without dynamic binding. And by the way, the employee and faculty method, I'm going to get to them in a minute, but they do have just like basic stuff, basic methods that display stuff on the screen. Okay. So for example, let's dig into it right now. Why not? For example, employee has a method called display, and this is a display method from employee, and it has a method display employee. You are going to see why we have two versions of it. That says this is a display employee method. So we can distinguish whenever one is called, whenever the other one is called. The faculty class extends employee, and similarly it has a display method and a display faculty method. So yes, the display method here override the display method that was inherited, but it's not that critical. Okay, it's not critical for this, for the sake of this example. So this is our overall structure, right? An employee class, a faculty subclass. They all both have display method, and they each have a class-specific method: display employee and display faculty. That's what is relevant for this example. So now let's go into the without dynamic binding example. It should sound familiar, or look familiar, actually, because this is a direct application to what we had a few slides ago. Okay? So what are we doing here? We take an employee E as parameter. So there is potential for polymorphism here, because employee has a subclass faculty. So I can be given an employee or a faculty at runtime as argument, and I'm going to refer to it as E. And then I use my newfangled instance of operator. If E is an instance of faculty, then I do the downcasting here. Okay? And I call display faculty. So I do the downcasting so that I can call the faculty-specific method, the method that only exists in the subclass faculty and doesn't exist in the superclass employee. Okay? Else, if E is an instance of employee, and this is kind of a little bit redundant, because if it's not an instance of faculty, but it was passed to me, as an employee E, there's only one solution left. It's going to be an employee. Okay? But just imagine that we have more subclasses, we have more difficulties here to sort out, whether it's just an employee or not. I'm going to go ahead and be exhaustive and do the test just to be safe. Okay? So if E is an instance of employee, then then I can do E.display employee. And why don't I have to do downcasting here, by the way? I did downcasting here. That seems to be the structure, right, that I follow with that kind of code. Why am I just using E here? It's working, but why? Yeah. And the parameter of the method is of type employee. So right now I'm looking at using a method that is specific to the superclass. Okay? Display employee. I have already a reference variable that refers to an object of the superclass type. I don't need to do anything. In the other case, I have to do something here because the type of E is employee. And the type of the object referred by E is faculty. So then that calls for downcasting. Okay? So just making sure. A little remark here that is actually pretty important. What if I put that test first? What if I first tested if E is an instance of employee? Do this. Else, if E is an instance of faculty, do that. Would that work as well? No. I kind of blurted it out when I put like a red warning, like that says the order is important, right? I'll have to fix that next time I use this this code for a slide. So yeah, it's really super important actually, and that goes back to what I was telling you at the beginning about instance of. Okay, instance of will tell you true if the second operand that you use, like the reference to the actual object, is actually an instance of the class that you specify, the class name, or any of its subclasses. So if I start by testing if E is an instance of employee, if you pass an employee as argument, it's going to be true. If you pass a faculty as an argument, it's going to be true. Because a faculty is also an object that is a faculty is also an instance of the class employee, because employee is a superclass of faculty. So instance of is not like detecting the actual class. It's more like detecting if you are compatible with a certain class. So if you are that class or one of its subclass. This is what being an instance of means, because the inheritance relation is transitive. All right, so if I were to switch the order, the first if statement would be always true. And therefore, I would never detect actually when I'm dealing with an employee. What about the over method? So I'm going to call without dynamic binding with E. I'm going to call it with F. Okay, in one case, it's going to call the special method display employee here. There we go. In the other case, it's going to call the method display faculty right here. No problem. This is actually, I would say, a bad way to use what we learned with object-oriented programming. Okay, we would use actually this kind of code only if we do not have a choice. If the design of our application calls for us to make an exception, or the requirement asks us specifically to make an exception in a polymorphic method, and go and check the type, etc., then yes, we have to do it. Otherwise, what could we possibly do? We could go back to basic polymorphism. So the lecture is kind of closing in a circle here. Okay, we're back to the beginning. I could, in this specific example, I could have gone back to basic polymorphism, and I could have said, all right, so what you want to happen is when I call the method with E, you want a certain version of a display method to run. When I call it with F, you want another version that has been overridden in the subclass to run instead. Well, let's just do that. Let's define one method, display, okay? And inside my static method here, the static polymorphic method, I'm going to take an employee, and I'm going to call e.display. End of story. No instance of, no if statement, not having to worry about the order of the tests that we do and stuff like that, okay? I just call e.display. And in my classes, what do I have? I have a method display in the class employee that just does the displaying, like an employee should do. And then I override this method in the subclass, call it the same name, same argument, same return value, same everything, okay? Compatible visibility modifier as well. And I do what? I do the displaying as it should be done in a faculty object. And that's it. So at runtime, this is what polymorphism is going to do for us. At runtime, I just wrote, no matter what E is given to you, call display on that parameter E. And that's it. And now, at runtime, we have this beautiful thing called dynamic binding. And dynamic binding is going to ensure that if E refers actually to a faculty, that's the faculty version of the method that's being called. If E refers to an employee, that's the employee version of the method that's being called. That's why polymorphism is interesting. You can write code once and for all, very simply, and then in the future, if 10 years down the road, somebody decides to add a bunch of subclasses to one of your classes, like for example the class employee, they add a bunch of subclasses. As long as they override display, your code that you are writing today will always work. The contract is, if I find a new version of display in that class that I never saw coming, I use it. If I don't, I use the one from the superclass. And this is very, very powerful in terms of making code, adaptable to future changes. For example, in all modern OOP programming languages, like the standard library, the JDK, for example, for us in Java. The JDK is ripe with example of polymorphism, for example of generic class, etc., because they want to provide you with the basic data structures that exist, in computer science, but they want to provide you with those data structures in a form that allows you to apply them to anything in the future. And that's why we deal with inheritance and polymorphism, really. All right. So I hope that helps make sense of, like the whole thing that I've been putting you through for the last two sessions. Before we are completely done with the lecture part, one more thing. Instance of is good or bad? Because I told you it's neat, and then I showed you an example where we could go back to basic polymorphism. So I don't want to leave you there. I don't want to let you exit the room thinking, well, that was just an purely academic exercise, and now that we learn about instance of, we can forget about it because it's always cleaner to go back to basic polymorphism. Now, sometimes you can't go back to basic polymorphism. And now we are like at the edge of the scope for this course. We are starting touching topics that are generally also addressed in an advanced programming elective. Okay? So I'm going to tread carefully. I'm not going to bombard you head first with the concept I'm about to discuss. Okay? But I want you to get a little taste of it. So there are times where using instance of is necessary. So we are going to illustrate that by talking about a method called equals. Just like toString, equals is one of those methods that is defined in the class object. So for the sake of this slide, let's say that this is how it's defined in the class object. It's not much more complicated, but let's just use that as our definition for the sake of argument. So public Boolean equals takes an object as parameter and return whether this is equal to the object. So by default in the class object, the equals method, when you call equals on a string or something like that, by default, if it was not overridden in one of the subclass, it would just look at the two references and compare them. So it would really answer the question, is that the same object in memory? So the default equals that is implemented in the class object is no better than us using the equal operator to compare two references and check if they are referring to the same object in memory. But we've seen that this is not always what we want to do. For example, with strings, I can have two string objects that are different, two different objects in memory, living at different memory addresses. And yet, I want to compare them in a way that if the text in them says the same thing, like both of them say hello, for example, then I'm going to say, yes, they are equal. So it's not good enough to just compare the reference, but when you don't know better, that's the only thing you can do. That's why this is how equals is implemented in object. But now the class string, which is a subclass of equals, subclass of objects, sorry, everything is, the class string is going to override equals and say, you know what, let me check if they are the same object. Of course they are the same. But if they are different objects, let me check the content. And then I'll tell you yes or no whether it is the same text that we find in both objects. So this is what we have for to start off with. And then we are going to be able to override in a subclass, for example, as the subclass circle. We are still using the example of geometric shapes here. We are going to be able to override, for example, the method equals. So public Boolean equals object obj. So the same exact signature, okay? Same return type, same number of parameters, same data type for the parameter, same name for the method. Yes, this is proper overriding, okay? Not overloading. And in the code of that method, what I'm going to do is I'm going to first take my object parameter. You may be tempted to say, I'm going to take a circle here instead of an object. If you are thinking that way, please hold on to that thought, because you just took like one step over the bridge here, over the abyss, and you're like in deep water, okay? Yes, that would be making sense, naturally thinking that if I'm in the class circle, I want to compare myself to circle. This is a much more thorny topic than it sounds. Okay, it's very, very delicate to handle. We are going to talk about that pretty much a little bit at the end of this example, and this is better left for like office hours if you are really curious. Okay, but please note for now that for now we are blindly following the rule of overriding, which are, I'm not going to deviate from what the original method looks like in any aspect. So if it says object is the type of the parameter, I say object is a type of parameter. And when you do that, you are in the easy case where overriding is going to work without problem. What are we doing inside the method? So inside the method, we are first testing if this equal object return true, because that's always true. Okay? If you give me 2 times a reference to the same object in memory, I don't need to compare the content. I'm going to say they are object. If I didn't return true, I'm still in the method. I'm going to test if the object that you give me is equal to null. If the object that you try to compare me to is null, no object, the answer will always be false. And this is kind of a pattern every time people override the equals method. They will go through those cases as well. Okay? And then finally, if I didn't return true or false, if the object is an instance of circle, so now I'm trying to do the test, the comparison that is specific to this class, the class circle. So I'm making sure that you gave me actually a parameter of type circle, and the way that I have to ensure that is with the instance of operator. And I do exactly the same thing that before, but I do it in 2 steps instead of 1 step. If anything else, just to show you that it's possible. I declare a variable circle over, and then I assign to it the typecast of obj reference into circle. So I can look at it as a circle now, and I'm going to compare the radius of this object with the radius of the other object, the object that was given to me as parameter. And that's it. Okay? So if all of this, if any of this didn't trigger, if none of this triggered, then at the end I return false. I don't know exactly what's going on. Most likely you didn't give me a circle. It's not null, and it's not even the same reference on this object. So I'm going to bail out. I'm going to say I don't know exactly what's going on, but false, it's not the same object. I went through all the cases where I would have to return true. My default answer is false. And that's it. So what was the big stench that I made here about object? Well, if we put circle here, it's not overriding. And we already kind of touched on that topic, okay? If I put circle instead of object, it's not proper overriding. So what is it? It's still a method with the same name. It's still a method with the same return data type. Same number of parameter. It's just the type of the parameter differed. What is it called? Overloading. So there is a thin line between overriding and overloading. Okay? Overloading is you provide multiple variants of a method, and they take different number or type of parameter. Okay? This is true here because I can overload another method that is in the same class than me, or I can overload a method that I inherited. We saw examples of that sooner in the lecture. Okay? So in this case, I inherit an equals method that takes object as parameter, and I choose to overload it. So if I do this, what's going to happen when I call actually this method on an object, let's say of class circle, and I pass as argument a circle? Well, that new method will be called, no problem. But what if I pass an object? Then the superclass version is going to be called. That's the rule, right, with overloaded method. With overloaded method, you have multiple versions. You look at the argument data types, and you match them to the parameter data types of one of the versions of your method. So overloading and overriding, without going like full depth on this topic, overloading and overriding can actually kind of overlap each other a little bit. You want to be careful. If this is the only thing you're going to remember from this 5-minute speech is you want to be careful. If you are asked to override, do it properly. Because if instead you slip and you overload, then your code is going to behave completely differently. All right? So I know it's a little vague of a warning, but we are going to go back to it and revisit it at the end of this code example. That's it for module 3 pretty much. So now what we have left to do is get ready for the next IE. That should be sometime at the end of next week, where I'm trying to keep a pace that is like every 2 weeks, we have an IE. So we have to get ready for this IE. And even more importantly, we have to look at some practical code together so that I'm sure that all those concepts, and there is a buttload of concepts, okay, that we went through for the last 3 lectures. All those concepts needs to be illustrated. And if the examples are still leaving like some gaps, don't hesitate to jump in and ask me about that. Okay, what if we did this? What if we did that? Why aren't we doing this? Those kind of questions are exactly what I expect for this last stretch of module 3, so that we can make it as interactive as possible. The next few slides are going to cover pretty much like a recap of everything you need to be able to do for the next exam. So I'm not going to read through this, okay? I try to do recaps frequently at the beginning of every session. I recap a little bit of the previous one to ensure continuity. But if you look at this slide and this slide, they are really like a menu for what you could expect to the next IE. As usual, I'm not going to try to go nuts on the very last topics that we covered. For example, instance of. Instance of is the last thing that I ask you to digest. I'm going to be nice about instance of in the next IE. The IE after that, yeah, it will be fair game. For example, the last IE, I told you I would not ask you to inherit from array list. This IE, if it's actually fitting the example that I'm developing, to inherit from array list, yeah, I fully expect that by now you are going to be ready. You had time to ask everything that you needed to ask about this topic. All right? So, if you go on Canvas, you can download already M3L8 slides starter template, something like that, or M3L8 starter template. This is exactly the code that I have on the slide here. So I integrated it in the slide for convenience. It's on Canvas. Please download it right now if you have your laptop. We are going to modify it real quick. This is the same example about audiobook, ebooks, and books. So nothing like really fancy, nothing that I changed since this. The main is just creating like 3 objects for now: book, ebook, and audiobook, and then displaying them. And then the structure is I have a superclass book, and then I have a subclass ebook, and I have a subclass audiobook. And really, only thing that I've been doing, okay, is providing constructors and providing versions of toString that override each other. So now I want us to do a few things with that code. So first, make sure you download it, make sure it compiles, okay, make sure it runs. It should compile and run. If not, please let me know. That means I messed up something. And once you are there, we're going to start talking about this to-do list here on the side. So this is a bunch of stuff I want us to do together on the code. Some of it I'm going to ask you to try it first, and then I'm going to give you the solution. Some of it we're just going to do it together live. Some of it we're just going to talk about it because it's trivial, okay? Let's start with the first thing, breaking dynamic binding. So this is our milestone to make sure nobody leaves the room without having at least a basic understanding of dynamic binding, okay? So one way that we can do that is try to explore our boundaries and try to figure out, through experimentation, what we can and cannot do with dynamic binding. So I've been lecturing you nonstop and boring you probably by now with everything that dynamic binding can do. Well, let's try to stretch that. Let's go a little further than this. So here's what I want you to do. If you look at the code, let me go back to the code here real quick. If you look at the code inside the main, this is the wrong code. There we go. That's better. Inside the main, we create a book B1, an ebook B2, and an audiobook B3. Okay? And then we display them, so it's done differently in several versions of the code. Don't worry, it's still just calling to strings here 3 times in a row. Okay? So this is what we have actually in the main. What I want us to do, what I want you to try to do, is to use B2 and provide me with any syntax that you can think of that would allow me to use B2, which is a reference to an ebook, okay, to execute the toString method from its superclass. If you are able to work on that, that means that the dynamic binding is at least semi-clear, and the use of the keywords like super, des, etc. is also clear. So you can try to modify the code and run it to see if it works, okay? I will circulate the room just in case you have questions, but I want you to give me some syntaxes to allow me in this code here. Where is it? There we go. In this code here, I want to be able to add a line here that's going to say, for example, system.out.println, and I want on using B2, I want to be able to somehow call toString from the superclass. Okay? All right, let's take like just a few minutes for that. But try anything, even like wild things that you're pretty sure that are not going to work. I want you to experience all the stuff that works, all the stuff that doesn't work as well. Okay? And if you're stuck, no ID, no, just raise your hand. Let me know and I'll call back to you. So what have you tried so far? Again, if you are stuck during those little exercises, don't hesitate to just like wave at me and I'll come help you, okay? There are different things that we can try to do to access the superclass version of a method. What kind of syntaxes have we seen that allow us to access superclass version of method? What kind of Java keyword? What kind of Java keyword did we use to try to access super class version of a method? Okay, I think it's maybe a problem of motivation right there. I'm not motivating you because I know that by now you all know that I'm referring to super, right? So what I want to debunk for you right now, I want to show you why some things that some of you are going to inevitably, sooner or later, think about doing, I want to show you why they're not working, okay? But that doesn't mean that it's a bad thing if you were like during this exercise, if you started going towards the super keyword, that's good thinking, okay? That's natural thinking based on everything that we learned. It's just that I'm going to show you now how it's not working pretty much, okay? So that's why we have those slides and this little exercise, is because it doesn't come naturally. So the first option that I expected some of you would mention is, well, I'm going to use the super keyword because super is my gateway pretty much to anything in the super class. So inside the main method, like right there where I'm defining B2, you know, some of you might have thought about writing just super.toString. Super.toString, the problem is that you are in the main method. This is the main method of the class M3L8 starter template. So when you are saying super here, you are referring to the class object. And that's not what we want at all, okay? So how do we refine this? Well, a possibility would be to say, okay, so I need to be inside the object referred to by B2. So B2 is going to be part of the deal. B2 dot, and now I want to go to the super class of B2, B2 dot super and dot toString. That syntax makes sense. If you think about doing something like that, I have nothing to reproach to you. It makes sense. It sounds natural. It's not allowed in Java. Okay? You cannot access super via a reference, like b2.super. Otherwise, the thought process, the thought process was pretty good. If you thought about this one, actually, that was pretty good thinking. What about, so this is like just syntactical. What about type conversions? We just learned about type conversion of reference data types, okay? How could I use type conversions to try to call the superclass version of toString from B2? Use upcasting, definitely. So what would it look like?
You would declare, declare or initialize an object of the superclass. And have B2 refer to that super object.
All right. So there are a few things I want to change in your solution, in your suggestion, okay? So instead of creating an object of the superclass, I'm going to convert B2 to the superclass. Okay, so the superclass is book. So I'm going to convert, doing to some upcasting, okay? I'm going to convert the reference B2, that is a reference to an ebook, to a reference to a book. Okay, I do that explicitly. I should be able to do it implicitly, but just to be safe, I'm going to do that explicitly. And then I'm not going to try to call reference a superclass from B2. I'm just going to say I want to call from that reference the method toString. Okay, and if I do this, then it's going to call the method toString in the superclass, right? No, unfortunately. Why? This is a part where we are double checking, right? Everything I told you about dynamic binding, think about dynamic binding and try to come up with an explanation. Why isn't it working? So let me try to give you a hint here. What if I am in a method and I get a parameter of type book. Okay? And I call toString on that parameter. What would happen if instead of being passed a book, I am passed a reference to an ebook? Dynamic binding would make it so that which version of toString is called ebook or book? Yeah, don't be afraid of saying something wrong. You know, we used to have like electric setups under the seats that I could trigger from the podium, but they removed them. So I'm not going to bite or do anything like that. Don't hesitate to be wrong. This is how you're going to learn, okay? But yes, ebook, because that's the philosophy of dynamic binding, right? Philosophy of dynamic binding is, well, I don't care what you declare your parameter like, but once I actually get an object from you, I'm going to check the type of that object, and that's going to tell me, you know, where to find the code that I need to run. So here, the reason for which I wanted to expose you to this is that this is something that I've seen actually a lot of students do when they think that they are still converting objects. They still believe that what we are typecasting are objects and not reference. So the thinking pattern here goes something like this. I convert the object B2, which is an ebook. I convert it to a book. And then if I call toString on a book, of course it's going to be the toString from the book that runs. But see what I did here, the way that I narrated this, I completely conflated everything that I tried to tell you to be careful about. I started looking at B2 and I said B2 is a book, is an ebook. No, B2 is not an ebook. B2 is a reference variable. It contains a reference to an ebook. The ebook object is over there. That sounds like I'm being, you know, like really picky, but if you understand that the object is over there and B2 is just a reference variable, when you cast B2 into a book, you're going to understand that you cast only the reference. So parentheses book of B2 is going to be a reference to the same ebook object. So I'm still dealing with an ebook object. But now the reference is a reference of type book, which means I look at it like if it's a book. So can I call toString on a book? Method matching says, okay, because it's defined in the class. Now, when I call toString on that object, what version is going to run? The ebook version, because that object is and always has been an ebook. So that's the difference between method matching, dynamic binding. Okay? You have to revisit this example. Okay? This little thing, sleep on it, forget about it, like in 2 days, reopen the slide, ask yourself the same question, try to come up with an answer. If you can't, Piazza, office hours, whatever you need, okay? It's not trivial, it's not easy, but these are the questions you need to be able to answer to check that you actually understand at a decent level, right, the method matching versus dynamic binding, polymorphism, and all that stuff. Now it's time for us to bring all of this together. You listened to the lecture, you heard about the concept, okay, you have some definitions that are all fresh in your mind, etc. It's answering those questions that's going to solidify everything. Okay, and now you're going to get your own clear picture on what's going on here. All right. So that was like the second option. Okay, the second option was I'm going to try to convert. Yeah, well, I can convert the reference all day long. It's not going to change actually the type of object. And dynamic binding is just there for that one reason. Triggers the code inside the object that is like the closest to the class of the object, right? So it doesn't work. There is no way actually for us to do that. Okay? There's no way with the syntax. There's no way with the typecasting that we explored, you know, for the last lecture or so. But I want you to be really sure and explicitly aware that this is actually not possible. What about to-do item number 2? So to-do item number 2, and we'll probably have to finish a little bit next session, but to-do item number 2 here has to do with writing a polymorphic method. So I'm asking you, just like I would, yeah, sorry?
So that line, that system that we just did, are you saying that should have given us an error?
It's worse than that. When I get a compilation error, I'm happy. No, I'm not really, but it's not going to give me an error. It's not going to even crash at runtime. but it's going to execute the toString version from the subclass. Remember, my goal at the beginning was I want to execute the toString version from the superclass. I want to bypass overriding. Here's the deal, okay? Can I possibly bypass overriding using some complex, typecasting or some syntax that I never tried before? Answer is no. And it's a good thing, right? Because when you write a subclass and you override, some method from your superclass, if I was able to bypass your overridden version, that would not be safe at all. That would not be safe at all, because that means that you override it because something had to be done differently in the context of your class. And the best thing that I can achieve by bypassing your overridden version and getting the superclass version to run, the best thing I can hope for is a bug. Okay, crash something, break something, denial of service, stuff like that. But that's it. Okay, there's nothing good that's going to come out of it. Does that answer your question fully? Okay, cool. Awesome. So the next to-do I want us to think about together is, what if we have an exam, hint, hint, and it says something like, add a static polymorphic method to our public class. So the public class is the one where the main is, okay? So that we can use it, the polymorphic method, from inside the main method to display information about all types of books. So I want a polymorphic method. We're going to call it display, okay, or something like that, display book. And I want it to be able to be called on any type of object, a book, an ebook, an audiobook. And I want it to pretty much display on the screen the text rendering, of that book, like pretty much using toString. Think of, what if I had only like 2 minutes to do that, literally. So it won't be complicated. What's the simple way to get this done? How many of you had something similar to this? Fair enough. How many of you were headed in that direction? Okay. So, polymorphism, not that trivial, huh? We have about a week to get you comfortable with stuff like that, okay? Just so that I give some context, this is, you can see it now, right? It's kind of like straight out of one of the slide, okay? It's a very basic example of, here's a polymorphic method. So I think what you need right now is you need time to absorb the content of the last two lectures. The best way to do that is review the videos, maybe. But if you don't like, spending an hour listening to a weird accent, or even times two, it's even worse, I've been told, then read the textbook. Very important, okay? But now we are done with polymorphism. We covered all the concepts together. So when you read the textbook, you can read the entire chapter, do your reading assignment now, and it's going to help you kind of solidify, the stuff that we talked about. Because yes, it's a lot of concepts, and some of them are definitely not trivial, okay? The good thing is that it's probably a good thing that we are going to finish this review exercise, at the beginning of next lecture as well, because pretty much if it's not fresh, if it's too fresh in your mind, then you cannot leverage the knowledge that you have, okay? So I want to look at one more example, and then we're going to stop for today so that next time, hopefully, we can get started in a condition where you have those concepts like in your head already, fresh, ready to use. So please, between now and next lecture, make sure that you use a reading assignment to help you out and ask questions. Yes?
I was thinking for the example we just did.
Yeah?
We could use the instance of, but then that would just be more lines of code.
That would be more lines of code, but you could make it work using instance of. Okay. Now remember what I said when I was done introducing instance of. It's really tempting. Once you discover instance of, it's really tempting to use it, because you can pretty much write the code. In your code, you can write the logic of polymorphism. But then, if polymorphism can do it, with dynamic binding for you, go for it. Go for the easier version of the code. Yes, you had a question?
That method wouldn't be public, it would just be static void.
That's a very good remark. Why didn't I make it public? I know that later I need a version of it that's not going to be public, but that version is not static either. So this is just something I forgot. Okay. So yeah, the question, just for the recording, the question was, where is my public keyword here? And the answer, I don't have a good answer, is it should be there. There's no reason this method should not be public. Sorry about that. I will fix it in the slide between lunchtime. All right. So let's get started on to-do number 3. And I would like you to kind of pretty much take it home and finish it up, okay? Try to finish it up, or at least advance it between now and next time. So to-do number 3 is kind of an important one. We are going to add a isMatching method. So we want to be able to write, for example, b2.isMatching b3. And the rules for us to determine if a certain book, audiobook, or ebook matches another book, audiobook, or ebook, okay, is as follows. The method returns a Boolean value, okay. We are going to define it in the book class. The parameter will be an object of class book as well, and it will return true if the title, author, and ISBN attribute match between the two objects. All right? So it's a method in the class book. The class book has the title, author, and ISBN attributes. Okay? So we want to just compare, this.title, this.author, and this.isbn to the author, title, and ISBN of a parameter that is given to the method. All right? The key will be, we start writing it in the book class, and now we're going to test it out. Okay, we're going to make sure it's working. So to test it out, we're going to go to the main method, and we are going to, I suggest you start by comparing B1 with a new ebook that you are going to create in the main. Create that ebook so that it's exactly the same than B1. So if we look at the code here, B1 is Kevin Mitnick, this book is not about hacking. Just cut and paste this, okay? Call it an ebook. So we're going to say this is going to be B4. So I'm going to comment this out, we don't need it. I'm going to say this is an ebook B4, new ebook, and I'm going to use exactly the same author, the same title, the same ISBN, and I'm going to say that it's an ebook, so it needs a file format. I'm going to say this is PDF. Say that again?
It's not on the projector.
So you guys have not achieved that level where you can see there. Just kidding. All right, so hold on. Hey, this is good. We have Control Z, or we should have Control Z. There we go. This is the biggest typo of them all. Nothing on the projector itself. Okay, so here's what I was rambling about without actually showing it to you. So first I wanted to comment out the thing here. All right, this was our previous experimentation. And then I was saying, let's take the book B1. And we're going to make a copy of the book B1, but this time it's going to be the ebook version of that book. So I say ebook, let's call it B4, new ebook, same author, same title, same ISBN. And because it's an ebook now, I need to add the file format. Here we are, PDF. Okay? All right, so this is just to allow me to test things like such as B1 is matching B4. I want to check if those are the same books. And by the definition I gave you in the slide, the answer should be true. Okay? These are the same book because they have the same title, ISBN. They have a different format, but okay, that's fine. So I could do something like a if statement, or I could just system.out.println is B1 the same as B4, and then put the result of calling this method. It's going to return a Boolean value. Okay? And then once you're done with this, just because nothing can possibly go wrong, we're going to also say is B4 the same as B1. There are some methods that you write in your classes that come with loggages. Okay? They are not just whatever you want them to be, or if you want to make them whatever you want them to be and it's a weird thing, then you'd better be super clear in the documentation. Okay? Is matching is one of those methods. Almost everybody, I can guarantee you, almost everybody, upon seeing that you have a method is matching in your class, is going to assume some mathematical property on it. Okay? So for example, if B1 is matching B4, then B4 should be is matching B1. Okay? That kind of symmetry there is going to be expected. That doesn't mean that you have to make it that way. That just means that you have to be super specific in your documentation, or I have to be super specific in my instruction to you, making sure that I clarify, what I want the rules to be, especially if I want them to be a little different than what common sense would assume. Okay? So in this case here, you're going to see what it does when you test it. Okay? But in this case, the whole point of this exercise and the rest of it is to show you progressively that it's not always that easy to reach a point where you have all of those properties that come with a method for free. Okay? Polymorphism, dynamic binding are going to get in the way, maybe not for this example, but in one of the following examples that we are going to look at carefully. All right. So this is what I'm going to leave on the table for you to try to complete home. Okay? Try to write a version of his matching. Use Piazza. Use office hours if you have problem. And bottom line is, if you are confused right now, if all of those concepts do not mean a lot right now, reread the reading assignment. Rewatch the lecture if you have to. Sorry about that, but that can help, trust me. And then ask a ton of questions. And never hold back a question because you think it's too basic. Okay, that's the number one thing that's going to hinder your learning. All right, thank you.